Hello Year 12 and welcome to the third video here for our sixth topic. We're learning about the sine rule. This is brand new. What is not perhaps brand new is this convention of labelling vertices or angles and the sides of a triangle. We use capital letters for the corners and a lowercase letter for the opposite side, right? Draw an arrow through that angle. You only hit one of the sides. It's going to be this one here. That's what we call the opposite side. And we use the same letter but lowercase for that one. Now, I need to use that convention because when we get to the sine rule, that's how we describe it. We say that A over sine A equals B over sine B equals C over sine C. Rightio? Or we can flip it over and I can say that sine A over A equals sine B over B equals sine C over C. This extends from the property that the biggest side of a triangle will be opposite the largest angle, that the shortest side will be opposite the smallest angle. It just makes it a bit more specific than that. Now, it is a wonderful rule that allows you to solve all sorts of problems with triangles. What you need is those two pairs of sides and opposite angles, or angles and opposite sides. I need two of them. So here's my first example. Calculate x, right, here's x, that's what we need to find, correct to two significant figures. I have the angle opposite x, that's good, and I have an angle here and the opposite side. So, I say that x over the sine of the opposite angle is 46 degrees. X over sine 46 equals 35 over sine 110. Right. Now, a little bit of algebra tells me that x equals 35 sine 46 over sine 110. And out comes the calculator. Where are you? Over here. Let's turn itself off. Right, so what do I want? 35. Hey, on. 35 sine 46 equals divided by sine 110. And there we go. 26.79. Two significant figures is going to be 27. All good? Wonderful. Now, moving on to our next example here, right? I have this thing going on, that's great. That's no good. I could work out the length of this side here, right? I've got this pair here, side and angle. I've got this angle, I could work out this side. But I want to work out this side. I need that angle to use the sine rule. If only we could work it out. Well, of course we can, because the interior angles for triangle are going to add up to 180. So, I'm going to say 180 minus 70 minus 34 equals, what's that? Minus... Oops. Is 76 degrees. Right? So, one of the things about a good big diagram is I can write that in there. There we go, we've got a 76 degrees. So now I have the right setup. Just be careful. This is how you make sine rule questions a little bit trickier, is by doing that. So, x over sine 76 equals 1.55 over sine 34. X is 1.55 sine 76 over sine 34, which is, to three significant figures, thank you calculator, 1.55 times the sine of 76 equals divided by the sine of 34 equals, now three significant figures, is 2.69. Three significant figures. Okay, that's the sine rule. Good big diagram. Opposite sides and angles. Right, opposite sides and angles. I need two pairs of those, and we can find one of the missing bits. Rightio, that's it for this video. I'll see you in the next one.